Okay, I think since now I already got some feedback from you from the best or the blur part. I asked you to submit before 3 today. So while waiting the answer, so I think I want to share that. Share this one. Okay, so this is from Nurin Tihani. So hopefully Nurin, you don't mind that I share your I mean comment or whatever. So okay, the best part, meaning that she fully understand. I like to determine the domain and the range, also finding the constraint. So, and then the blur part, I still need time to sketch graph that contain that contain the constraint. So you mean that sketching the domain, right? Yes, you need to do a lot of exercises because this course need, you have to be able to sketch the graph, especially the hardest part is in 3D. So you have to do a lot of exercises and you have to sketch by hand. You cannot, okay, please don't use any software. You can use the apps, the software or whatever online platter just to check your answer, okay, but for the exam sake you have to sketch by your own. Okay, so next maybe I just pick randomly. Afif. Okay, Afif. Okay, multivariable function, easy to understand. That's good. Everything clear. That's good. And yeah, Rakin Siva. Okay. Best part, drawing the graph according to the equation is still sound familiar. The blur part containing domain and range, as I always I had problem in that. Okay. Okay, so meaning that I would say as a conclusion, you have to do a lot of exercises. So I think I already attached the tutorial. So maybe you have to spend some time to do that exercise, even though I'm not asking you to do that, but it is good if you try spend some time to to answer the question in the tutorial. But sometimes the question is quite hard, okay, and also it is good if you have a past year exam question, so you can ask, you can get from your senior or maybe you can get from the library. So okay, so that is that I want to share. Okay, now we move to the so our lesson today. Okay, I want to share the this one. Just a second, yeah. Okay, so for the domain and range for the two variable functions, so we've done that. So now by now I'm assuming that you can find out any example about the about finding the domain and range and sketching of the domain for two variable function. Okay, but also for three variable function. Now the most important part is to sketch the graph. Okay, so this is I'm not sure whether this one is a bit fun or something boring for you. but it is hard for me to explain because I have to explain online. So I hope that I mean you will get some understanding, even though I try to explain through online. Okay, so here about the graph. Okay, about the graph is, okay, before, actually I don't like to refer to the slide. Okay, let me explain what is the thing that you want to focus now. Okay, so here you have the function. The function, okay, before you okay, I would say that in your Internet 1 you have learned a lot about this particular function, right? You have hyperbolic function, you differentiate them and so on. Okay, so this kind of function is called single variable function. Okay, so when you have a single variable function, how about the graph of this function? What is the system that you have to sketch the graph? What is the dimensional system? Anyone can answer me? What kind of dimensional system for this particular graph? Okay, maybe I call name Angelique. Are you here? Angelique? Can you answer me? Can you hear me?
Yes, doctor.
Okay, so what's your answer? So what is the dimensional system for this particular graph? 1D, 2D, or 3D? Okay, let's say I give example y equal to x squared. So what is the graph looks like? 4D. You know what is 4D mean? 4D means that the graph, you can feel the graph. 3D you can touch, right? But 4D you can feel. So is that possible for this particular graph? Okay.
No.
All right. So this one, because of okay, about the dimensional system. So how can we give a name 2D, 1D, 3D? So 1D is impossible. Okay. I mean, I'm saying about the normal thing. Okay. So 2D means that when your variable, you have here x, right, and then you have another variable y. So you have only y and x. So the only two, so meaning that you have something 2D. When you have 2D, you must have axis, right? So your axis here is y versus x. So we have a 2D system. This is called 2D because you have only x and y. X is independent, y is dependent. Dependent means y depends on the value of x, but for x it is independent because you're free to choose any value of x. Okay, so now this kind of graph is very common for you, right? So for example, last time you have sketch circle, and you also have what, the graph of cos, graph of sine. That is something that you can draw on the board, you can draw on the paper, but you cannot touch it, right? You cannot touch, right, that line. You can just draw on the paper. So this is 2D. That is from your Angel Maths 1. But now you have multi-variable function. So for two variable function, now we extend the number of variable. So now we put another variable z. Okay, so z is the function of we have x and y. So now we say that x, y, it is they are independent variable. You are free to choose any x and any y. But because they are coming in pair, so you have to make sure you fulfill the constraint, okay, that you have done for the domain. Okay, you sketch the domain because x and y, even though it is you free to choose, but then still you need to fulfill the constraint or the domain. Okay, this is independent, but z dependent because it's just like output. It depends on the xy that you choose. Okay, so now if you want to sketch this graph, so what kind of dimensional system that we have to use here? Anyone want to answer? Just now we have 2D, now we have?
3D.
Yes, thank you, 3D. Why it's 3D? Because you have X, 1, you have Y, 2, and you have Z, 3. So when you have 3D, meaning that now you have 3 axes. So normally the orientation is in this form. X, and normally I'm just using the regular form. Actually, you can change the orientation. So X, Y, and this one, Z. Or if you want to change the orientation, you can also have Y, you can also Z here, and you can also have the X here. Okay, with the condition that you label. If you insist to use this orientation, then let me know. You have to label. If you don't label, let's say you sketch the graph. If you don't label, so I'm assuming that you have a standard orientation like this. Okay, so maybe your sketching is incorrect. So please label. Label is very important in maths. Okay, same goes for you when you sketch the domain. So you need to sketch the interception. Sorry, you need to label the interception, the center of the circle, and so on. Okay, so that is a two variable function. So meaning that the thing that you have to sketch here in this course is in this form, 3D. So it is not easy to sketch in 3D. You can imagine in your mind, but it is hard for you to sketch on the paper. Okay, so that is the hardest part. Yeah, because the exam say you have to sketch on the paper, so that's why you have to practice in sketching by hand. Okay, so now that is the graph, okay, in general. But how about if you have three variable function? In the last video, I hope that you already watched the video. May I know? So please be honest. Any one of you still I mean did not watch the videos yet? Is there any of you still didn't watch the video that I just uploaded at 2 just now? Okay, so I'm assuming that everyone have already watched the video. So for three variable function, in that video I already introduced you the three variable function. Yeah, so for three variable function, so can you expect next if you have xy, so next you have what?
Z.
Yes, thank you. We have x, y, and then z. Okay, so now just now you have total variable here x, y, z, 3, then you have 3D system. So this one 3D system, three-dimensional system. So now can you expect what kind of dimensional system that we can have for this particular function?
4D.
Yes, thank you. 4D. Right. Let me ask you, is it possible for us to sketch the 4D system by hand? Possible? By hand? By hand? No. Yes,
No.
of course you cannot. Because the 3D is just like this, X, Y, Z. Something that you can touch. But another dimension, for 4 here, there is extra dimension here is the feeling. Okay, feeling. For example, maybe you have used the what we call that glasses for the glasses, right? That is okay for 3D glasses. You wear that glasses and you feel that everything in front of you is just like real. You can touch that, isn't it? Have you tried to use that glasses, 3D glasses?
Yes.
Okay, it's something that just like real, right? But not 4D. Instead of you put on the glass. For example, you watch a movie and you are wearing that glass, and then the 4D, the other part of the dimension, which is the fourth one. What is the fourth one? For example, you're watching a movie and you are wearing the glasses, and then I mean, maybe you jump into the water. So where is the another dimension comes from when you jump into the water? You feel wet, right? You feel wet. I mean, there is a real water will coming in front of you. That is the 4D. Okay, so that is the 4D, meaning that we cannot, for this course we are unable to sketch 4D, but we still want to know the property of the three-variable function, but not sketching on the 4D. Okay, so for that I will explain later when we comes to it. Okay, so that is the thing that we want to focus, but I'm sure that we have not enough time to spend a whole, but I will continue with the video. Okay, is there any question?
No.
Okay.
Doctor.
Okay, now we back to the slide. Okay, okay, so the graph of the, we start with the obtain the graph of two variable function first. So as I mentioned before, so the graph should be in 3D, and we have discussed on the domain and the range. So after we done sketching, you know to sketch, then at the end I will relate what is the I mean the relationship between the domain, the range, and also the graph. Okay, but that one is after you done on sketching. So that is you I hope that you it's become clear for you. Okay, so for this I just want to focus on sketching first. Okay, so here let's say as I mentioned before, your sketching of the two variable function should be in 3D. So let's say you have a surface. Okay, for your information, your sketching on 2D, so let's say you have y-axis plane. Let's say you have quadratic smiling curve. So that is called curve. Okay, so you have to understand some terminologies. Okay, for when you have curve, meaning that you're sketching on 2D. So this is called curve. Okay. But you're sketching on 3D, this is called as surface. So this is called surface. So when you talk to someone else who are taking this subject, maybe from other section, so when you say that curve, so they understand curve means sketching on 2D. And when you say about surface, so they should understand the sketching on 3D. Okay, so how can you have a surface? Okay, let's say we want to plot the point of 1, 2, 3. Okay, so now I'm asking you to plot the point. Okay, only a single point. 1, 2, 3. So the point of 1, 2, 3. Okay, so I give you 10 seconds to plot that point on 3D. Okay, so meaning that this is the value of x, and this is the value of y, and this is the value of z. Okay, now I want you to find out where is x equal to 1, y equal to 2, and z equal to 3. So let's say we have a regular or the common orientation. You have x here, you have y here, and you have z here. Have you done that? Okay. Have you done that? So, anyone? I'm just asking, have you done? I'm not asking you to show. Don't worry. Yes. Okay. So let's check. Okay. So let's see. This is 1, and then maybe this is 2. Okay. So now that is the point on 2D system on XY plane. Okay. This is 1 and Y is 2. That is called 2D because you plot on the y-axis plane, so you plot on 2D system. And then where is the 3? 3 is belongs to the Z, so you just project. Okay, you just project, and then let's say that point is 3. Okay, and then that is the point of P. 1, 2, 3. Okay, that is only a single point. How about you have another point? Let's see the point here. This is on 2D. So this is 3 sketching in 3D. So here the point is located on y-axis plane. And then I project this point, and you got that point in 3D. Depends on the value of Z that you have. And we have many more points there. Point here, and then you project, so you have this point. And this one, you project, you have the point. So imagine if you have a very many point inside the what we call this, sketching on 2D. This is called domain, the value of the x and y. So any point that you choose, okay, I should use the large. Okay, you choose here, they will at the end project onto the surface. So on here, project around here. So we call that the combination of all the set of Z you can have, or you will have surface. You understand?
Yes, doctor.
Okay. So that is the idea. Now this is the domain. So for any point or any value of xy that you choose and you substitute into the function, will give you the value of z. So the combination of all the value of z, you will have surface. So that is the graph for 2D system. Two variable function. Okay, so that is the idea. Okay, so here this is 3D coordinate system. Okay, in the question, the exercise I gave you yesterday, one question is about coordinate planes. I know that when I saw your answer, I would say everybody has the similar statement, exactly the same. And then when I check, yeah, you are taking from Wikipedia, right? Okay, betul tak? Is that true? Yes. Okay, but do you understand? Do you understand what is actually coordinate planes? Okay, coordinate planes actually, if there is only plane, because when I read the statement, they say only lying on xy. You don't mention zy, you don't mention zx. So actually, the coordinate plane, if there is one plane, so it's referring to okay. So because the statement that you gave me for the last yesterday's exercise, it is about only on y-axis plane. So this is one of the coordinate planes, meaning that there is only y-axis, z missing, no z. Okay, you plot onto the system. Okay, the sketching onto the system where there is y and x. So this one, okay, tell me for this plane, where you can find this plane on this this diagram. Okay, how can we find out this one? So where is this is the plane, right? This is the plane. So where you can find this in this diagram? Where is it? At the base, yes, that's correct. At the base, which is this one. Okay, this one because of when the z is always equal to 0. Okay, so here this is one of the coordinate plane, which is you can give a name, whether you can use you can say that z equal to 0 plane. So it is understood it is just like a floor or base, or you can say that xy plane, also possible. Okay, and that is one of the coordinate plane. And how about this one? It's just like a wall, right? Okay, imagine now last time when I have class, because we have the physical class, right? So everybody in the class, so I say, okay, imagine now you are in the classroom, and and here is the whiteboard. Okay, this is the whiteboard, this is your board, and I'm sitting here. And where are you? You are, okay, this is the chair and the desk, and you are here. Okay, so meaning that xy plane is the floor, right? The base. Do you agree with me?
Yes.
And then
Yes, doctor.
okay, and this one is called front wall, where there is a board, the whiteboard in front here. I would say front wall. So this one, what is the name of this particular plane? So
Why is
the,
that?
sorry.
Why is that?
Yes, YZ plane, because there is no x, because x is 0, right? So this one is called as, we can say that x0 plane. Okay, or you can say that zy plane. So this is another coordinate plane. Okay, and then you have another wall, it is called side wall. So there is a window. Okay, and this is your teacher. Okay, so now this one is your side wall. So the side wall here is another coordinate plane. So this is called as y equal to 0 plane, or you can say that exact plane. Okay, you can use either one. Okay, but be careful when you use the y0, x0, and this one z0, because if someone said that, okay, I have y equal to 0, but you have to make sure y equal to 0 is a line or is a plane. So it depends on what you have, what you are discussing about. If you are discussing about curve, so y0 is a line, right, which is, we call that as a x-axis, isn't it? But if you're talking about a surface, so y0 is a plane, which is coordinate plane. So you have to, because some students they get confused. So please refer to what is the thing that you discuss about. If you are discuss about surface, so y equal to 0 is a coordinate plane. But if you're talking about 2D, so y0 is a line, which is x-axis. Okay, so so the combination of these three planes, we call that as coordinate planes. So now you understand what is coordinate planes mean?
Yes.
Because normally in exam, there is a question asking you to sketch some diagram. Okay, where the graph is the combination of few or some equations, not only one or single equation, the combination of all the equations. So one of them, maybe they will say that sketch the wedge, okay, the wedge of the given functions and also coordinate planes. So I'm afraid that if you don't understand what is a coordinate planes mean, so you are unable to sketch. So this is very important. Okay, this term coordinate planes is very important. So hopefully you understand that. Okay, is there any question? You can
No.
interrupt. If you don't understand, you can interrupt. Okay, don't worry, I'm okay. Okay, so this is about the octant. I'm not sure whether you understand the octant. Am I saying that sketch the cone in the first octant. Okay, so if you don't know what is the first octant mean, so you cannot sketch. Okay, so if you understand quadrant, do you know what is a quadrant mean? Quadrant, what is quadrant? Quadrant is something lying on y-axis plane 2D system. So this is called first quadrant, right? This is called second, third, and fourth quadrant. Okay, but this is 2D. Now you extend into 3D. So when you have 3D, so we divide. For 2D we have four what we call that, 4 things here. Okay, but when we have 3D, so it's become double. You have 8. So that's why there we use the word octant. Okay, so meaning that when you have a first octant, so this is octant 1, meaning that first octant, so your x, your y, your z, they are all positive. Okay, the value of x, y, z are positive. So whatever point lying in the first octant, so the value of x, y, z are positive. Okay, and then here for the second octant means that y positive, z positive, x negative, and so on. Okay, but the common octant that normally been used in exam is first octant, because I don't know why the first octant will always become favorite, because maybe easy to be sketched. Okay, I don't know, but maybe this year we ask you to sketch on the fourth octant. I don't know. Okay, so you have to know about the octant. Okay, so what is the surfaces that you have to sketch in this course? So because for your information, surfaces is not easy to be sketched by hand. So the surface that we will sketch is just a simple equation or simple surface. Okay, but maybe we just need some modification, so just to make it harder. Okay, so so I would say that the surface or the equation that we will go through is not so complicated. The complicated is because you don't spend some time to sketch or to do exercise on sketching, so that's why it's become complicated. Okay, so you need to do a lot of exercises, especially on sketching. Okay, so here the surface that we will sketch is plane surface. Okay, what is plane surface? Can you give me an example plane surface or flat surface? Can you give me an example? Flat surface? What is a flat surface? Okay, let me call your name. Fadlin Amira. Are you here, Fadlin Amira? You ada kat sini ke?
Yes, I am.
Okay, give us an example. What is the flat surface or plane surface?
Table.
Table, yes. The surface of table, yeah, that's correct. Or also, you can have, I'm not sure you can see me, right? This paper, this is also an example of flat surface, flat. So this is also flat, and this is also flat. Okay, that is a plane surface. And for number 2, number 3, number 4, that is called curvy surface. This one. So this one I will say flat. In simple word, okay, flat surface, something flat. And this one is a bit curvy. Okay, what is curvy means? Something sphere. I don't have a ball here to show you. Cylinder. Okay, we have this. Okay, cylinder, right? So this is something curvy. Quadric means, or maybe you have this form. You can see from your side, this is U shape, right? But actually this is the form. So quadric surface can be part of the curvy surface. Okay, it's just a name. Don't worry, I never ask you in exam or in exercise to give me a name of that particular surface that you sketch, but I will ask you to sketch the graph based on the function given. Okay, so meaning that the thing that you will sketch is something flat and something curvy. Okay, so that is our scope. Okay, so this is too wordy, right? I'm sure that if I explain every single word, you don't understand. Okay, so I will just go through with the example, and then after we done the exercise, after I explain, so please refer back to the step here. Okay, I don't want to refer to it here because I'm sure that you don't understand. Okay, now we start with to sketch the plane surface. Remember, we have two kind of surfaces, plane and curvy. Okay, now we start with a bit simple, very simple one, plane surface. So this is in general. Okay, so for that plane surface, why we call that as a plane surface? There is a reason why we call that plane surface. Okay, now look at the equation given to you, all of the equation. What kind of equation that we have? What kind of equation? Yes, thank you. Fatin, are you going to linear? Yes, we have linear. Because of all the equation that we have here, they are all linear equation. So that is why your surface is flat. Do you understand what I mean? Because your line, your graph here is just, they are all line. Just maybe this one is just a flat. Okay, this one also flat. No slope, right? But this one there is a slope, negative slope, and this one maybe positive, maybe this one negative, so it's still a straight line. So that's why you will have the plane or flat surface. Okay, but because of there are few steps that you have to go through, so I split the linear equation here into three parts. Okay, okay, can you spot the difference between them, the first one, the second one, and the third one? Can you spot the difference between the three types of linear equation here? What is the differences between them, or what is the difference between them? Apa beza between this, okay, between this and the second one? What is the difference? Variable, yes, that's correct. Okay, for the first part, we have only one variable. You have x equal to 0, y 0, z 0, z equal to 5, and maybe you have y equal to minus 10. Okay, and the second one you have two variable, and the third one you have three variables. Okay, remember, even though the equation given to you, whether they are one variable, two variable, three variable, but the thing that we discuss right now is about two variable function. Okay, so when we talk about two variable function, the sketching must be on 3D. Okay, because I'm afraid that I will you will, I'm sure that you will confuse. You will say that x equal to 0 supposedly is a line, right, which is y-axis. Do you agree with me? Yes, you are correct. You are correct. But that one is on 2D. Now we are saying about 3D. So the graph is not y-axis. Okay. So there is a way for you to, or the step for you to sketch the graph. Okay, but for the first three, where's my pencil? So for the first three here, okay, x0, y0, z0, we have sketched them before this. What is this? What are these graph is? X0, y0, z0. What are the graph of this? Anyone? Yes, yes, that's correct. These are coordinate planes where Z0 is the floor. Okay, imagine just now we have, imagine you are in the classroom. So Z0 is the floor, okay, the base, and Y0 is your side wall where is there is a window, and then X0 is your front wall where there is a whiteboard. Okay, so that these planes are called coordinate planes. But how about Z equal to 5? Do you have any idea? Z equal to 5. Just now we have Z equal to 0. Okay, so now 3D. So where is Z equal to 0? The base, right? Z equal to 0 is the base, which is down here. Down here. And actually, the size of your plane is not only limited by this area. Actually, you can extend down here, and you can extend behind there. So this one is x negative. That one is, this is x, this is y, and this is z. And then meaning that you can extend your plane. So this one is for z equal to 0, your floor. How about z equal to 5? Hello? Are you there? Anyone want to help me? Z equal to 5. So where is z equal to 5?
Atas sikit, Doktor.
Yes, that's correct. Atas sikit tu kat mana? Where is the Z5 meaning that? At?
Dekat Z-axis.
Yes. 5. So now your plane is here. Okay. So because this one is just 5, Z equal to 5. It is easy for you to imagine and easy for you to sketch. Okay. But okay, that's fine. So what else in the, okay, Z equal to 5. Let's say here, I'm asking you to sketch Y equal to negative 1. Now Y equal to negative 1. Okay, maybe 5 minutes. 1 minute. Z, Y equal to minus 1. Sketch the plane of Y equal to minus 1. Don't give me a line. Okay, this is about two variable function. We are talking about two variable function. So your sketching should be not a line but a plane. So this is X, this is Y, Z. And you can extend this because you have negative 1 here. Okay, anyone want to share your answer? Maybe you can say and share through the WhatsApp. Okay, for those who have problem with the internet connection, I will share the video recording. So I record this one. Have you done? Can you turn on your video so that I know that you are working on it? Is that possible for you to turn on your video? Oh, someone already sent. Okay. Just a second. Here I will copy the. You can see that one, right? Oops, sorry. Okay, so this is from your friends. Yeah. So this one is x-axis. So this one is y. And this one is z. And this one for y minus 1. And this is the plane. So that is correct. Okay, so thank you. So meaning that that is the okay, because this is 3D, so sometimes what you imagine is not different as my imagination. Okay, because we imagine the same thing, but our sketching can be different. So that is the hardest part actually. Okay, but it's okay. We will try our best. Okay. So that is for one variable function, which is for me easy, okay, to be sketched. Now we extend our linear equation into two variables. I mean the equation has two variables. Okay. So now we look at the first one, y equal to negative x plus 6. Okay, so y equal to negative x plus 6. Okay, so the first step, when you want to sketch 3D, you need something which is called as traces. Okay, traces. That is a very important terms that you have to understand. Okay, before you obtain the sketching on 3D, you must sketch something on 2D. Okay, once you get the sketching on 2D, then you have to combine and then you will get the surface. So when you are doing sketching on 2D, so it is called as traces. Okay, so now the first step, you imagine this one. I mean, you are thinking about the sketching on 2D first. So meaning that you have a line instead of a plane or surface. So what is the line looks like? It is linear, right? Linear, it is a line, and you have negative slope, and then your interception at y is 6. Okay, for this you have to be able to sketch the 2D things. Otherwise, you cannot get the surface or the plane. Okay, so this is very important. If you don't remember that, then you have to do your own revision. Okay, so now the trace. So the trace, so you sketch the line first. Okay, about the axis, whether you have to use y-axis or you have to use yz or you have to use z-axis. So it depends on the equation that you have. So now you can see the y and the x only, right? There is no z. So meaning that your trace should be on y-axis plane. Okay, where the z is 0. So now you draw the line, and the line is this one. Okay, remember, as I mentioned in the video, we are not drawing, so we don't bother about the scale. We just sketching, okay? As long as you label the intersection. So for y-intercept, you have 6. How about the x-intercept? How we obtain the x-interception? Any idea? How can we obtain this one? The value here. You have to label.
We try to put 0 on x and
Yes.
y.
We set y equal to 0. So when you set y equal to 0, you have minus x plus 6, then you have x equal to 6. So you got 6 here. Okay, this is not always the same. Depends on your equation. Okay, depends on your equation. So that is called trace. Okay, you have only single trace here. Now you have to convert your trace into 3D. So how can we do that? Okay, so tell me, you want to have the standard orientation or you want to change the orientation, which is based on the y-axis that you have? Which one?
Change.
Change. You mean change? You want to have y here? I mean,
Yes.
okay, you want to have y here and x here, and this one supposedly z.
Z.
Okay, thank you. Okay, so that meaning that it depends on you. If you want to have a different orientation, so your sketching will be different. So meaning that if you have a physical exam, you cannot just look at your friend answer. Maybe they have a different orientation. Okay, so if this is the orientation that you choose, then okay, the first step is you have to draw again this line, the similar line on the plane that you have. You have y-x here, meaning that you will have the same line like this. You can see that this is the trace that you have, y-x. So the line is the same because you have the same orientation. If you choose a standard orientation, let's say you want to fix here x, this is y, and this is z. So your green line supposedly down here, where the intersection will be the same. Or if you want to use this orientation, so your line here. Okay, so you don't need to provide both. Don't waste your time. So just choose either one. Okay, so let's say as your friend wished just now. So we refer to this. Okay, next. This is still a line, not yet a plane or a surface that you can touch. So now how can you obtain the plane or the surface? So the next is, after you provide the trace, you have to do the projection. So projection is the process. How can you obtain the projection? So the next is projection. You project. In Malay, I think unjuran, kan? Unjuran, is it? Projection. Okay, you have to project. You have to provide the projection. So how can you have the projection here? For that, you have to imagine. Okay, here, before I proceed about the projection, I want to ask you. You have to ask yourself, for on the trace, which variable is missing? On the trace, which variable is missing?
Z.
Okay, so Z missing, meaning that in 3D here, you are looking from Z. So this is you. So in your vision now, you can see this one. Understand? Okay. So meaning that Z missing, so meaning that you are looking from Z axis. So in your head, in your vision now, you can see this line, which is this one. Okay, now imagine. So now back to the projection. So imagine in front of you. So this is you. In front of you, there is another y-axis plane. So that is your imagination. So imagine in front of you, there is a new or there is another y X. Or you can put behind there as well. But normally to be easier to be sketched, we put in front here. Okay, so this is also Y and then X. And then next, you draw again the same line, the same green line here. Exactly the same, and they are parallel each other, which is that one. You have to use a ruler, okay? Exactly the same. Okay, actually they are the same on the new y-axis plane that you create. Okay, now this one also passing through the 6 and also passing through the 6. Okay, similarly, if you want to imagine there is also y-axis behind here, so you draw the line again. I mean the same line. And actually you can provide very many parallel line. Okay, but it's enough just one, don't waste your time. Alright, so next we want to complete the plane. Okay, so you have a combination of the same line here which are parallel, and in order for you to complete the plane, so you have to sketch the projection line. So next is called projection line. So what is a projection line? A line which is passing through the Z, because you are sitting at the Z here, so the projection line should be parallel to the Z axis here, which means that this line and also this line. So you can see the plane, right? So that is your plane. Understand? So maybe
Yes.
for those who still confused, you have to rewatch my video. So I'm sure that it's not so complicated actually. Okay? Because we already 4, sorry about that. Okay, so here, please do another example in the notes. Okay? So, any question before we dismiss? Okay, if there is no question, then I think that is all for today. So, we meet again next week. Okay, guys?
Okay, doctor.
Okay.
Thank you,
Okay,
doctor.
thank you very
Thank you,
much.
Thank you,
doctor.
doctor.
Thank you, doctor.
Thank you,
Thank
bye.
you,
Thank you,
doctor.
doctor.